So one of the more important values that the government collects is what's known as the Consumer Price Index, otherwise known as the CPI. And this is used in articles that you might read that is trying to compare the cost of insurance 10 years ago compared to the cost of insurance today. They would try to compare these two numbers, but because of inflation, you can't just look at their absolute values at those times. So you have to adjust the older value into future money. So that's what we're going to use with CPI for, is to adjust for inflation. So what is measured in this CPI index is a few things, and then they average them together. So the big pieces are, how much does housing cost, how much does clothing cost, how much does transportation cost, education, communication, other goods and services, recreation, medical care, and food and beverage. So they collect all of these costs every single month to see if the cost of the items are going up or the cost of the items are going down, and then they just do a calculation on it and generate a number based on how much more expensive is it now than it was back in the mid 80s. That was their baseline, the mid 80s. So they generate a table of values pretty much every single month, but the one I'm going to show you is one generated um, that is an average per year. So I stole this off the internet from a government website, and each year from 1947 all the way up through 2019, the average CPI of the year I've listed out here. Um, and generally, what we're going to do to calculate inflation is go back to good old formulas: new minus old divided by old. So if we do a new minus old divided by old based off of these CPI numbers, and then times that by 100, and change it, of course, into a percent, this becomes known as inflation rate. So what is the inflation rate per year based off of these numbers? So for example, the average So I know the average cost of groceries in 2019 is about $175 a week. And what I'm interested in is adjusted for inflation, how much would these groceries have cost way back in 1947? So on the table, we're going to be looking at this number way down here. And generally in my problems, I just tell you what the CPI is, and I don't use the table values, I just randomly choose some numbers. But it all works basically the same. So in 2019, the number, the CPI, um, if you can't read it in the video, it is 255 point, I'm only going to go one decimal place, 0.7. All right, and then I need to look up 1947, 47, yeah, 1947. And the CPI in 1947 was way up here, it's 22.3. Now, when you're talking about these CPIs, and we're generally going to be talking about new and old, obviously the new one is the current one or the closest to the year that you're already in, and the old one is further back. 1947 is definitely the old value. So when I do new minus old over old, I'm going to indicate inflation with an I. We're going to get 255.7 minus 22.3, all divided by the old, which is 22.3. And if we calculate that, 255.7 minus 22.3, make sure in your calculator this does the long line, gives me a nice set of parentheses. I would highly suggest, again, just subtract first, hit enter, and then divide by 22.3. And that way you don't make any silly mistakes. So this is 10.5%, Oh, I haven't even multiplied by 100. Oh dear. That's not 10.5%. Times 100. There we go. And then change it to a percent. All right, so times 100. So this is 1046.6. 1046.6%. And this would be the change in value over time. So then I'm asking, how much does $175 in groceries that we would buy today compare to how much they spent back in 1947? Well, that also becomes an oldie but goodie formula. So we're going to take our inflation rate and we're going to use grandma's formula now. So new equals grandma 1 plus or minus x over 100. Now, it's plus if it's, positive inflation, and it's minus if it's a negative inflation. And yes, there are times where the inflation was negative. So the new value we already know because $175 is today's money. So that would be the new one. 175 goes here. The old one is what I'm curious about. How much did groceries cost in 1947? 1 plus that inflation rate divided by 100. Now, to solve this, we need to get g by itself, so I need to divide both sides by this whole thing. So I'm going to, in my calculator at least, do this part. So it's going to be g equals 175 divided by, in parentheses, 1 plus 1046.6 divided by 100. Now, if you don't do the parentheses, you'll get the wrong answer. So make sure you put a parentheses right after the division sign and then end it off with a parentheses.
75 divided by, parentheses, 1 plus 1046.6 divided by 100, and parentheses.
So, funny, the groceries, the grandma number here, would have cost $15.26. So $175 in groceries today corresponds to someone spending about $15 in 1947. So it's amazing what inflation will do to money. All right, so let's say we found a receipt for a diamond ring that was purchased in 1963 and the ring only cost $750. How much would that ring have cost if we bought it in 2000 adjusted for inflation? So the first thing we need to do is look up the CPIs for 1963. 1963 is here. So that would be 3063. So 1963, the CPI is 3063. CPI. Okay. And then in 2000, turn of the century, 2000 is over here. It's 172.19. 172. And I'm just going 2 decimal places. Don't know why. It doesn't matter in the long run. So to find the inflation, we're going to use the percent change formula. New minus old over old times 100. So in this case, the inflation is going to equal the new value is the most current one, which is 2000, 172.19. The old one is the 1963 value, 3063, all divided by the old one, which is 3063. So 172.19 minus 3063. Okay. All divided by 3063. 30.63. So and don't forget, times by 100. It's one of my common mistakes. So 462.2. 462.2, and because we multiplied it by 100, it is now a percent. So the inflation from 1963 to 2000 was 462% overall. All right, and then we want to change the value of the ring. Now to change the value of the ring, we're going to use Grandma's formula. And I'm putting plus here because this is a positive 462. It's very rare for it to be negative, but it is possible. So do I know the new value? Well, no, because the old value in 1963 was $750. So this is going to be new is equal to $750, the old value, plus 462.2 divided by 100. I think that divide sign is just a little too long. So 750 parentheses 1 plus 462.2 divided by 100. So today, or I'm sorry, in 2000, the ring would have cost $4,216.50. So that's how CPI works. It's not too hard, and I like going over it because it brings back the percent change formula and the grandma formula. Another way of talking about inflation is inflation tells you how much money is becoming devalued as time goes on, but it doesn't talk about purchasing power or buying power. So this next example, which is the best way to talk about buying power and how it relates to inflation, is the following. So a loaf of bread today costs $2, and if we're going to buy 100 loaves of bread, it would cost us $200. Over the next year, inflation rate was 10%. So next year, the loaves are going to cost $2.20 per loaf. So the question is, how many loaves can I buy now? Oops, did I spell that right? Well, whatever. How many loaves can be purchased for $200? And this is the essence of buying power. We knew we could buy 100 loaves of bread last year with $200, so this current year, after 10% inflation, I'm curious, how many loaves of bread can I buy with the same amount of money? So to figure this out, we're going to take the amount of money I have, $200, and I'm going to divide it by the cost per loaf, which makes sense. That'll, if we did that earlier, it would have been 200 divided by 2, which is 100 loaves of bread. So 200 divided by $2.20 per loaf. So now we can only buy around 91 loaves. So we have lost the ability to buy 9 loaves of bread. So 9% in this case represents the buying power. And in this instance, this buying power is going to be considered a percent decrease. We are losing the ability to purchase 9% of the bread that we used to be able to purchase. Notice that 9% buying power is really close to the 10% inflation rate, they're never exactly the same, but they generally, because one's based on the other, they're in the neighborhood. So a formula for buying power is simply 100 times your inflation rate, but not as a decimal. So if it's 5%, just throw 5 in here. Divided by 100 plus the inflation. So the buying power has this simple formula. So let's see how it works with my inflation rate of 10%. So this becomes 100 times 10 divided by 100 plus 10, better known as 110. So this is 1,000 divided by 110. 110. And we get the same number. It's about 9%. So this 9.1%, I didn't include the 1% for the loaves of bread. This represents the percent decrease in what you can purchase based on 10% of inflation. So, I mean, it's a weird concept, but then you can kind of start seeing if you used to be able to buy 100 items of something, you're going to lose the ability to buy, if you multiply this by, just drop the percent, you lose the ability to buy 9 of those items anymore. So that's what buying power is all about. So, what happens if inflation becomes so great that money from one month to the next almost becomes worthless? Is a topic called hyperinflation. Generally, it's known as inflation that is bigger than 50% per month. We're not even talking per year here, it's 50% per month. So, one of the more recent inflation rates that were hyper was in Venezuela. And one of their maximum inflation rates per month, by the way, was 300,000%. So just to see what this really does to people, let's look at how much it costs before this inflation rate for groceries and then after this inflation rate for groceries. So let's say we have in May, groceries cost $175 in Venezuelan money. I don't know what that is. And I'm curious about how much it's going to cost in June. So we're going to set up our grandma formula. We already have our inflation rate. It's definitely positive. So I'm looking for the new value, and I have the old value. So this becomes new equals 175 parentheses 1 plus 300,000 divided by 100. So in June, that would now cost $525,175. So this is what happens when a country goes through hyperinflation. You might be earning this much money a week to pay for your groceries, and then the next month, all of a sudden, you have to come up with an astronomical amount to buy groceries. So this is just to buy simple groceries. And that's why it's quite important to keep track of inflation rates, because when they start getting big, then it turns into a snowballing effect. So here I have the Mickey Jones earned $75,400 this year, and her husband earned $68,200. They're filing jointly, which basically means they're married, which has a standard deduction of $11,500 and an individual deductions of $2,000. So the first question is, what is the Joneses' taxable income? So we can start using a tax table. So to find their taxable income, the first thing you have to do is, well, add the tax or add the income. So we need to know their total income first. And then what we're going to do is subtract the deductions. So it's pretty simplistic. Sadly, this year there are no individual deductions, so you're going to get taxed on um, things that when I was growing up, I wasn't taxed on. All right, so we're going to add the income first. So we start with $75,400, and we're going to add on to that $68,200, and this will be the total income. Let's see, that's 600. It's 13. It's $143,600. All right, and then from that, we're going to take away the standard deduction, do it in like this color, which is 11,500, and we're going to take away the individual deductions. Now, be really careful about this. Individual deductions means per person. So Nikki is going to save $2,000 off of her taxes or her income, and so is her husband. So we're going to subtract two of them. All right, 143,600 minus 11,500. And then we're going to subtract 4,000 from that. So minus 4,000. So our taxable income, based on this calculation, is 128,100. So this is known as taxable income. Okay, this out of the way for a second. So then we can go to the table because the table is based off of taxable income. And 128,000 is going to land us on this tax bracket. And the way you read this tax bracket is it's not too hard. It's actually kind of easy. We know how much money we earned, 128,100. So guaranteed without a doubt, we have to pay this amount of money right off the bat. So our tax is going to start off with $7,762.50. Now that is the tax on the money before 65,000. So it's a tax on these two brackets added together. All right, and then we need to find the tax of the amount of money over in excess of 65,000. So then I'm going to go down here and subtract 65,000 from this. 1,000 minus 65,000. So we have to calculate a 23% tax on $63,000. So 23% of $63,000. And that'll also be part of our tax. So it's going to be these two added together for our total tax. All right, so delete 23% of $63,000 is $14,490. If we add on the $7,762, we'll end up with a tax that is $22,252.50. So that would be the tax that the Joneses would have to record on their tax forms, and then other things happen after that, credits and deductions and all those weird things that they throw at taxes, which makes them really complex to deal with.